Hi, I'm Andre Patno. I'm the Director of Solutions Integration for Emerson. Um, in the 35 years with Emerson, I've had many different positions, but currently I support system level innovation related to the cold chain in an effort to help our customers add more value to their solutions. So today I'm here to talk about Emerson R290 and low GWP solutions. I'm thrilled to be part of the NASRC Sustainable Refrigeration Summit. So thank you very much for allowing me the opportunity to talk today. What I'm going to be talking about is some of the regulatory drivers around R290. Take a little bit of time to talk about what we have today that's ready from an R290 compression perspective and what we've got coming down the line. We'll also be looking at condensing units. How do we apply those R290 compressors into units? What do we have available now and in the future? Give you a snapshot into the performance and life test stands that we have for A2Ls and A3s, and then talk a little bit about some of the remodel options using new equipment that are CARB compliant. So we'll get right into it. You know, from an end user perspective, there's absolutely no doubt that efficiency, sustainability, and cost of ownership are top of mind when they're thinking about transitioning to low GWP refrigerants. And there's a lot of drivers that make those decisions. So if we start on the left from the refrigerant regulatory drivers, I think if you're on this webinar, then you understand the direction that we're going from high GWP A1 gases directed to 150 below world. And when that happens, of course, you're into mildly flammable A2Ls. And if we get below a 5 GWP, we still have some A2L options, but we fall into naturals like ammonia, propane, CO2, all having their own challenges and caveats, but providing an opportunity to get to those low GWP areas. And really, part of that, from a driver perspective, from a regulatory perspective, there's a lot of activity happening in codes and standards to make sure that we can increase the use of these lower GWP gases, including, of course, R290. And the 3-year code cycle, 2021 was 1 year, and then waiting 3 years, the next code cycle falls to 2024. So a lot of things are going to happen starting in 2024 with higher charge limits on A3, we expect anyway, and also A2Ls. So a lot of activity going there. Moving to the right of the page near the top, I talked about DOE and energy efficiency regulations continue to find their way into equipment. That's a good thing. We're driving efficiency standards. But we also need products, compressors, condensing units to be able to match those efficiency standards. So, you know, Emerson's working hard in order to do that. We're also working to meet the higher charge limit demands that are expected to come around in the 2024 code cycle, whether that's 300 grams for closed cases or 500 grams for open, and also meeting the less than 150 GWP requirements that other customers may want if they don't want to go straight to a propane or a CO2. So we've got to be ready for that. So from a product expansion portfolio perspective, what I'm going to do today is just talk about the small stuff related to R290. So the top left, we're looking at compressors. So I'll touch on that, how we're applying them into condensing unit, what capacities do they have, and then I'll talk down here about our infrastructure to support those A3, A2Ls. But not, you know, we also have controllers and displays for those small display cases and units and that type of stuff. We have facility management system and even other types of controls and drives that can support it. And of course, on the bits and pieces, if you will, the flow controls, the electronic valves, the sensors that enable some of these technologies are also provided by Emerson. So from an R290 compression lineup, let's have a look. From a fixed speed to the top left corner here, 1/8 hermetic reciprocating 1/8 to 1.25 horsepower, available R290 production now. And the next slide will show you what those capacities ranges are. But we also have scrolls, horizontal scrolls now in R290, fixed capacity up to 3 horsepower. Samples available now, and in about 6 months, we'll have production. Moving to the variable speed hermetic lineup, we have one lineup here of 1.8 to 7.8 production now. And that gives you, of course, variable capacity modulation, even on those small display cases or spot merchandisers. And then moving to a little bit larger equipment to the right, we have approvals including R290 in horizontal with variable speed. And by the end of calendar 21, the end of this year, we'll have production and samples are available now. And again, you know, you need controls to support those products, and you need valves and sensors as well, that we have those approvals in that part of it as well. So from a medium temp compressor R290 lineup, you can see here that fixed speed, 60 hertz, in a recip, we go up to about 6,000 BTUs, okay, in the recip. In the fixed capacity scrolls, we can go up to a little over 16,000 BTUs. And these horizontal scrolls will be launched, as I mentioned, in about 6 months from now. When you get down to the variable speed lineup, hermetic, recip, variable speed, at 5,000 RPM, a little under 8,000 BTUs, with a nice wide range of capacity modulation. And when we look at the scroll, 3 different displacements can get us all the way up to 30,000 BTUs. And that would require special approvals, of course, with a capacity that large, because that would be beyond today's charge limitations. But we have the product ready to meet those challenges when they occur. That's medium temp. Low temp, similar story. Of course, it's low temp, so the capacities will be a little less because of the nature. So around 3,500 BTUs, low temp recip, scrolls can get you up to about 8,500. And from a variable speed scroll, can get somewhere in the 15,500 at a 5,000 RPM. Now this is a BPM motor, it's not an induction motor, so it's a specialized variable speed motor to be matched up with the Copeland drive. So that's a compression liner. Now, when we look at scroll comparison from an efficiency perspective, ERs and BTUs per watt, the yellow represents 404A refrigerant, the blue 448A, and the green R290. And you can see that we're the conditions that we've chosen are 120 condensing, 40-degree return gas temp at a -10 evaporating for a 6,000 BTU scroll. The R290 is 6.8% more efficient. As you get into a bit larger compressor, its efficiency increases a bit to 12.5. And as you get into, again, a little bit larger compressor, efficiency increases slightly. And that just means that as you get a little bit larger, it makes sense that your efficiencies are a little better, because the actual tolerances in the internal parts are the same at a small compressor as they are in a large compressor. So it's a little bit easier to mitigate those losses with larger surface areas. So that's a positive step when we talk about R290 and efficiencies and the direction that we want to go from an industry perspective. Now, what are we doing to take those compressors and roll them into condensing units? Because we also make condensing units, Emerson does. So from a fixed speed hermetic perspective, we have those in production right now, up to 1.25 horsepower, R290 rated. What we have now, samples on request, are using that horizontal scroll in a low profile condensing, air-cooled condensing. So that can go on top of cases and gives retailers merchandising flexibility, because it is an air-cooled version that can sit on top of the case and easily be moved around. We're at the sample request state right now for R290. Variable speed, recip, R290, we have them built into condensing units for sample requests right now. And from a indoor modular solution, we have 448, 449. If we get asked for the R290, we'll be able to develop that and provide those samples. But this is, again, this is a water-cooled unit that, again, sits on top of the case, has the entire controls drive package in order to facilitate the application of that distributed type architecture, and the 448 can handle up to a 12-foot case, whereas if it was R290, you'd have to have more smaller modules to accommodate that larger truck. And again, products to support it are available. So from a capacity perspective, medium temp in a condensing unit at 60 hertz, we're looking at about 7,000 BTU in those small condensing units. And in a low temp perspective, somewhere around the 4,300 BTU range, low temp. From a system lab perspective, it's not all about just having the compressors. We have to be able to have the capabilities to test these A2Ls, these A3 compressors and condensing units. So we've invested heavily in the development of labs that are currently in place. Some have been in place since 2017. Others have come online with the additional investment that we made in our Sydney facility. But you can see the amount of performance stands for A1 and A2Ls, 25 performance stands, 140 life test stands, all brand new equipment with data acquisition equipment. When we're talking about propane, we've got 3 performance stands and 14 life test stands. And then in CO2, I'll talk about that, not so much in this particular presentation, but performance stands, life test stands, and even 3 booster rack systems that help us to understand, develop, and grade our products. So that's kind of the investment going on there. And the other thing I wanted to talk about is from a retail perspective, there's a lot of trends that are driving decision making, and I'm not going to go through all of those. Those are things that we all have to deal with in the industry, but what's important is a collaboration with our customers more than ever so that we can work together to collectively integrate our domain knowledge and provide lower total cost of solutions to our customers. And one of the things we get asked of is, it's all fine and dandy to have all new stuff for new equipment, but what about if we want to remodel or retrofit our existing stores and be compliant? What options do we have? So here's the 3. They're not all the options available, of course, but if you take a look at, our traditional centralized HFC, but if you want to start modulating or start adding some refrigeration or retrofitting those stores, well, Emerson's come up with a digital medium temp X-line condensing unit, which now gives you ease in having multiple loads on a 1 compressor condensing unit, whether you're using mechanical valves or PWM, electronic valves, and have that integrated into the condensing unit control, which has the ability to communicate with higher level aggregator controls and pushing out to the cloud. So that's one option, under 50 pounds. And we'll also have the A2L options when codes and standards are adopted for that. In the middle of the page, whether those are R290 units that are made by several manufacturers that gives you the option of a 150-gram charge today, or a 448, 449 option that Emerson currently makes in our integrated display unit. This gives you an option whether air-cooled or water-cooled. And because you're looking at 448, 7 or 8 pounds, maybe 9 pounds in the largest case, or modularized 150-gram units with propane, there are options there for you to have. And I mentioned many manufacturers make it. And the one on the right is a new scroll booster. It's a low-pressure architecture that Emerson developed about 3 years ago, leveraging the advantages of a low-pressure gas like a 134A, but lower GWP versions of a 513A, or even future 1234YFs with when codes and standards apply, is really understanding how to use a low-pressure refrigerant in both low temp and medium temp. And we've got dozens of stores out there operating with that technology today. And all of these are retrofit options or even new store options if you wanted to, but they all have the benefits of higher efficiency, simple commissioning because of the electronics that are built in, and quiet operation. So that's pretty much what I wanted to mention, other than the fact that from the A2L candidates that Emerson were asked us a lot, what are you focusing on right now? And those are the 4 refrigerants initially here in North America we're spending time on 454C, 455A, 454A, and 1234YF. Our European colleagues have also been working on other A2L and options in the field. So this is all I wanted to talk about with regarding to R290 and what Emerson's been up to in that space. And I thank you very much for the opportunity. Hi, my name is Andre Patnode. I'm the Director of Solutions Integration for Emerson. And in the past 37 years with Emerson, I've had various roles, but currently I support system-level innovation related to cold chain activities in order to help our customers drive higher value. And today, I'm thrilled to be here as part of the NASRC Sustainable Refrigeration Summit. And my topic will be Emerson CO2 solutions, investments that we've made in CO2, and total cost of energy studies I wanted to touch on that's top of mind for many retailers. You know, as I was putting this presentation together, I was going through the NASRC annual report and looking at their objectives, and really a lot of the objectives that they had align themselves with some of the topics that I'll be talking about, whether that's driving higher performance, ensuring service readiness, training perspective related to natural refrigerants, or working on areas to try to achieve cost parity, lowering costs, trying to figure things out. So today I'm going to try to talk about CO2 compression. So only what has been updated recently. There's a couple things I want to touch on. I also want to touch on CO2 controls. There's some things that you may not be aware of that's happening in our design, development, and testing that I'll bring you up to date. And then CO2 training. What are we using for training? What do we have plans for? And then talk about additional transcritical booster lab capabilities that we're going to have here in the U.S., which I'm really excited about, and talk some more about some lab investments and a total cost of energy study that I think many of you will be interested in what's going on in that space and where we're at. So this image obviously is a transcritical booster system, fairly basic one with the use of parallel compression. And our transcritical semi-hermetic products, of course, are rated for parallel compression use. I'll be talking a little bit later about specialized controls for CO2. But now I just want to focus on a few things related to semi-hermetic transcritical and subcritical scroll compression. So from the transcritical compression perspective, number one, our largest displacement compressor, the 4MTLS 28ME, we've got 9 displacements in our lineup. And you can see from the 40 down on the bottom left here, that's about 40,000 BTUs at plus 20, 45,000, all the way up to the new one will give us about 310,000 BTUs at plus 20. And I'm excited about that for this launch at the end of this year, because it'll give us opportunity to get those to be in that large commercial light industrial space, because you can need less compression to do the work. So that's really important. The other thing that's very important is the fact that all of those 9 displacements are now approved for 70 hertz operation. And I know that in some cases when you're at peak capacity demand, you want to be able to overspeed that compressor a bit to meet those capacities instead of adding a larger compressor. So we have the ability to do that now. And application engineering voltages are being completed. Width reduction program, that's interesting as well, is we're reducing the width, the overall width of the compressor by 17 to 23%. That'll be completed at the end of 21. And that really gives the OEMs flexibility on the rack size. When you have 4, 5, 6 of these things on a rack, you can cut down the size of the rack. So that's an important consideration. On the subcritical scroll perspective, we launched a digital 58 model. So we have 6 displacements already in subcritical scrolls from about 21,000 at minus 30 Fahrenheit rating point all the way to 104,000. We have a digital version, which means that it has capacity modulation capabilities down to 10% of that 104. We had a 34,000 digital, we've just added middle of the range 58, which gives, again, designer flexibility in meeting capacity requirements as system conditions change. And we also have semi-hermetic low temp compressors rated 135 bar, really up to 140,000 BTUs. Plus, the last thing I want to mention is we're increasing our stocking levels here at our Mount Comfort, Indiana location, and that's good news for OEMs when they're given short lead times to build racks. So that's the compression side. On the control side, I'm very excited about this because the industry needs a control that is simplified, has integrated CO2 native features built in, and can really help contractors in the field. And that's why I'm excited about the Lumina E3 CO2. The E3 is actually a rack control facility management system that is replacing our legacy E2, which there's about 250 CO2 systems running with the E2. But now the new E3 CO2 will have embedded native CO2 applications like the integrated high pressure and bypass control, gas cooler, flash tank control. We'll have simplified setups, troubleshooting features with it. We'll integrate parallel compression, adiabatic gas cooling, and all of the high ambient strategies part of that. So it's a lot easier to set up, not only for the contractor in the field, but working with OEMs to simplify line setups as well. So that's a big deal. And we're completing the parallel compression testing at our Helix Innovation Center, where we have a transcritical booster system. And the results we're getting are amazing, transitioning in and out of transcritical or supercritical mode with the parallel compression. So we're thrilled about that and excited that these features are being layered in through 2021. Other product that we're very excited about is a new next level CC200 case control, which not only has Modbus communication, but has BACnet IP. So you can actually communicate directly to the cloud from the case if you choose to do so. And so customers have been asking for that direct IP functionality. And so we've added all types of features to this case control. We've got expansion modules that can do up to 3 expansion valves on the one case control, whether they're pulse width modulated, whether they're stepper, as well as an electronic EPR as part of that loop. We've got touchscreen display that can sit at the case, plus mobile applications. So we've got all the flexibilities and the features that our customers have been asking for. And for all refrigerants, including CO2, later this year in 2021. From a CO2 training perspective, I mean, this is near and dear to my heart. When I started doing CO2 business development with Emerson back in 2014, our first trainer was completed in 2015. This is a 3rd generation hands-on mobile training unit that gets shipped around North America. And prior to COVID, it had a North American tour, a few stops in California, New York, and Florida. But we want to amp that up, of course, coming out of the pandemic, having a unit that can be dedicated to the U.S. market. So we're working on that, plus training sessions online that are being developed now. This is a fully functional, you can walk 360 degrees around it. There's DX evaporators for low temp, DX for medium temp. You've got your low temp, you've got your boosting feature. Plus there's a dry ice function in here as well that customers can actually see the formation of dry ice by just dropping the pressure super fast with our compressors and having the refrigerant turn to dry ice and then watching it sublimate and turn back to a fluid. So really cool training unit that we want to amp up the training. We're also adding some functionality to our software, our product selection software, as well as new software development that are in the works for OEMs. So we're thrilled about that. Natural refrigerant lab, something that we already have a transcritical CO2 lab at our Helix Innovation Center. But we're adding an additional facility, transcritical lab in Sydney, Ohio, plus a condensing unit test facility. Now, I know that NASRC did a survey about 6 months ago talking about the need and for CO2 condensing units. Well, we need to understand that. from our own perspective so we can help support our customers as they build these out. So that's why we're doing it. That's why we're building this transcritical booster lab in Sydney, Ohio. This has got all the functionality of a real supermarket. It's got parallel compressors, medium temp, low temp, even the low temp with the split suction. We'll have the ability to do adiabatic gas cooling, dry gas cooling, heat reclaim, and even false load 100% of the system with gas cooling, false load, or have everything on display cases and walk-in coolers in combination thereof. So we have complete flexibility to be able to manage the dynamics of the system. Plus the fact that our low temp cases are all equipped with dual defrosting, electric and hot gas defrost, to understand those dynamics. And so it's a unique opportunity for us to learn, for us to collaborate with industry to make sure that we can improve the performance and try to drive costs down and cost of ownership down when it comes to CO2, not only for booster systems, but as I mentioned, also condensing unit application, single condensing unit application. So a lot going on in that space, and of course, a lot will continue to happen. Now, cases, we've got about 2,500 square feet, Sydney, Ohio, and there's going to be 18 different display cases, low temp, medium temp, island, plus a walk-in cooler and a walk-in freezer will not be in this area, but will be tied to the particular rack. And as I mentioned, we'll have full case redundancy by false loading as well as this active management. So that's going to give you a snapshot for the transcritical booster lab. But it's all part of a bigger picture. Emerson investing $100 million in the Sydney facility in Ohio. And part of that investment is labs. We're redoing all of our labs in the middle centralized the building, which really can improve on safety of our employees, improving on light. You can see on the left, there's a lot of natural light coming in. Because the labs are close to each other, interaction between the technicians, the engineers, the scientists that are working in those labs will be in close collaboration with each other. So there's a lot of positives to pulling all those labs into one area, including labs that are already existing, like sound and vibration labs and material engineering, power electronic labs. Those are all adders beyond even what we have here. So we're pretty excited about that and the addition of the CO2 facilities I've talked about. And finally, I want to touch on total cost of ownership study. This is something I've heard NASRC talk about, and I've seen them report on different things. And it's not like we're trying to compete with others. But when you do your own study, you get to understand it much better, the ins and outs of what you have to go through, and to give you a better appreciation, a better appreciation for how to help our customers and how to collaborate more with industry. So we've worked with Cushing-Turrell to come up with basically 8 full system designs. You can see on the left, and I'll cover them on the next slide a bit more, but each one of those design architectures has these specifications on the right. 25,000 square feet, 450,000 medium temp with 14 cases and 5 coolers, about 90,000 low temp, 7 cases, 1 freezer. They prepared refrigeration schedules for each architecture, electrical schedules, floor plans, refrigeration floor plans, electrical floor plans. We've done LCCP analysis for 4 climate zones on all of those architectures. And we really need to understand that total cost component. We're working with OEM partners on equipment costs, with contracting partners on understanding what the installation costs, commissioning, service maintenance contracts would be on each one of those for those different climate zones, so we can get a better appreciation for what that really means. So the architectures we're talking about, I mentioned 8 different architectures. Centralized, top left here is our baseline 448, 449. Transcritical booster, adiabatic gas cooling, of course, electronic valve, and hybrid cascade system using 448, 449 on the top. Distributed scroll packs, micro-distributed using R290 water-cooled, single condensing units, scroll booster with medium temp racks, and these two are pretty close to the same. This has a combination of 2 or 3 compressors, all handling to meet the low temp loads. And the one here on the right, again, is a low pressure for medium temp or low temp, but the low temps have individual compressors on each case, which also allows them to be dual temp, medium and low temp, gives them that flexibility. So those are the main 8 architectures. Like I said, we've done all the refrigeration schedules, all the floor plans, plus we're doing the LCPP analysis for these are the 4 climate zones that we've chosen. We weren't going to do all of them, but these are representative. So warm climate, zone 2, Houston, Bakersfield, California, Dayton, Ohio, and Minneapolis. And kind of gives you an idea. This is just happens to be the annual CO2 emissions, CO2 booster with adiabatic, of course, you would think is the lowest, and it is. So those are things that we're working on right now. We're just finalizing the results of the maintenance and commissioning, and we plan on presenting our findings this fall. So thank you once again for this time. I'm really thrilled to have been able to participate in this refrigeration summit. Thank you.